Your directions for tonight's homework. You have one set of directions. It says solve, period. Be sure to reject any value of x that is not in the domain of the original log expression. Give the exact answer. Then, where necessary, use a calculator to give a decimal answer rounded to 2 decimal places. Alright, so what's going to be different about tonight's homework is that the original problem, the beginning problem, will already have at least one log in it. So these are actually log equations. They come with a log in them or an ln in the equation. They'll already start that way. So we just call these logarithm equations. They start with a log. Okay? So if you have one baby log in a problem, this will be the easiest one that you see. If you have one little log, you're going to make sure that it's isolated, meaning that it's completely by itself. There's nothing being multiplied times your log. There's out to the left. There's nothing being added to the log, subtracted, divided into the log. It's completely by itself, just like in example 1. So when the log is completely by itself, the easiest thing for you to do, because log base 5 of x won't simplify without your calculator, is to rewrite it in exponential form. Y'all remember the swirl method? 5 to the 3rd power, go towards the equal sign, is equal to x. And once you rewrite this in exponential form, your brain goes, oh, I get this. X has got to be what? 125. If you really have time to practice these a lot, you can solve this one without any work at all, because you realize, hey, that really means 5 to the 3rd is equal to what? Okay? 5 to the 3rd is equal to x, so x is equal to 125. Alright? So some of them will be, like always, they're always going to start off easy and then they get harder. So example 2, ln of x is equal to 3. ln of x is equal to 3. So if your equation already has a log in it, check to see if it will simplify on its own. Will ln of x go away? Will the log go away in ln of x? No, because that says e to what power is x. So it's not going to go away, but it is by itself. Okay? It is by itself. The understood base is e. You might have to write that down to get your brain going to what you're going to do next. Once the log is completely by itself, you're going to rewrite it in exponential form. So this says e to the 3rd power is equal to x. And then since we know e is really a number, it's in our calculator, please don't use 2.7. Don't round e. Use the correct value in your calculator and round at the very, very end. So remember, you got to do second ln to get your e to come up. You're going to raise that to the 3rd power, and that's going to be approximately equal to 20.09. So this would be one of those where it says if you need to use your calculator, use your calculator. We would have to use our calculator in example 2, but we probably could do 1 without a calculator. All right, example 3. Log base 2 of 4x plus 1 is equal to 5. Log base 2 of 4x plus 1 is equal to 5. So my question is to you, will this log evaluate on its own and will the log go away? Because sometimes it will. It's not. Is it by itself? Okay, as soon as you realize that one log is by itself, you're going to rewrite it in exponential form. So we have 2 to the 5th power is equal to 4x plus 1. 2 to the 5th power is equal to 4x plus 1. 2 to the 5th is 32. And then you could have solved this problem in the 8th grade, I bet, from this point on, right? Subtract 1 from both sides. So 4x is going to be equal to 31. Divide both sides by 4. You can get a decimal or a fraction here. I wrote it in decimal form, and I wrote 7.75 if you wanted to do 31/4 or 7 3/4. Doesn't matter there. Any of those would be correct. Okay, so my first three examples, the logs were already completely by themselves. All right, in example 4, the log's going to be hanging out with some friends, and you're going to have to move those friends before you can write it in exponential form. So in example 4, I have 7 plus 3 times ln of x is equal to 6. 7 plus 3 times ln of x is equal to 6. So in example 4, our little ln, if we think about where it is, it's not by itself. So you can't go writing this equation in exponential form yet. The ln of x has got to be completely by itself. So what would you do first to get it by itself? You would subtract 7. So that's going to give us 3 times ln of x is equal to -1. Then you're going to divide by 3. And then you might be thinking that this one's going to give you an error because of the negative. Okay? But this is a different type of problem. So now your little ln is by itself. Your understood base is e. So let's rewrite it in exponential form because it'll help our brains. Once we get it in exponential form, it actually makes a little bit more sense. So we have e to the -1/3 is equal to x. So can we raise something to a negative number that's not negative? Yeah, we can raise e, which is about 2.7. We can raise that to the -1/3. That just means we're going to do 1 over the cube root of e. But we're going to let our calculator do that. What's e to the -1/3? About 0.72. Okay? We're not trying to take the log, the ln of e, okay, and saying it's negative. We're just raising a number to a negative power. You can raise any number to a negative power. That just means you're taking the 1 over the cube root of e. Okay? Questions before we get a little bit more difficult? Everybody pretty good with that? Alright, do y'all remember seeing anything like this on your take-home quiz and saying, I don't have a clue what I'm doing? A little bit? Okay, well hopefully you'll know which ones you can go back and look at. Alright. Anybody thinking of something that we've tried to say all along in the last couple sections? Logs and radicals are not friends. So the first thing that you need to do with this problem, instead of just stare at it, is to change the square root of x plus 4 to x plus 4 to the 1/2. Okay? And then when I asked you, is the log completely by itself? Another thing that you could think of is there any property that we have used, or any rule that we have used? There are 3 of them: product, quotient, and power rule. You see any of those that would apply to this problem?
Power rule.
That power, we don't want that power there. If we can take that power and bring it out in front and multiply it times our log, our life will be a lot easier. So that power is going to go whoop out to the front, and we're going to do 1/2 times ln of x plus 4. We don't want that power there. It completely complicates things. So it's just like, man, we feel so much better. That's another assignment that I've turned in and I'm closer to finishing this semester. It comes out to the front. Now my next question is the ln by itself? No, it's not. It's being multiplied by 1/2. So you're going to multiply both sides by 2. And then finally your ln is going to be by itself. Completely by itself. And when your ln is completely by itself, that's when you're going to rewrite it in exponential form. The understood base is e. So you're going to go e to the second power is equal to x plus 4. E to the second power is equal to x plus 4. Then once we get it in exponential, it's kind of converted back to our original language when we grew up. Okay, it just is more familiar to us. So we're solving for x. So we got to subtract 4 from both sides. So you're going to do e squared, second ln, e to the second, get that number, and then you're going to subtract 4 from it. Practice this on your calculator and tell me what you get. 3.389, and that would round to 3.39 if our directions say 2 decimal places. So this is where our three rules are going to start coming into our solving. So we've got the product, the quotient, and the power rule. So we actually use the power rule right here. All right, example 6. All right, 6 is going to be the first problem that we see that has more than one log in the problem to begin with. Oh, yay. All right, before I start this one, I realized that there was just a little thing that I have not been talking about every single time. In the directions where it says, be sure to reject any value of x that is not in the domain. I've not talked about that at all except when I read the original directions. So let me go backwards to a few problems. All right, so let's look at example 3. So we said that x is 7.75, okay? When it says remember to reject, so we have this rule. Y'all remember the rule, the definition of a log? What does this quantity right here have to be?
Greater than 0.
Has to be greater than 0. So you have to take your x, you got to go back into any log that was in your original problem, and you have to say, we'll use example 3 as an example. If x is 7.75, does 4 times 7.75 plus 1, is that going to always be greater than 0? Is 4 times 7.75 plus 1 going to be greater than 0? Yes. So that means the value that we said was our answer is in our domain. So what you'll have to do is you'll have to take your answer every single time and you'll have to just mentally check it. So in example 4, there's the value that follows your log. That value right there must be greater than 0. So what did we get for x? 0.72. If you put it back into that x spot, that value has to be greater than 0. Is 0.72 greater than 0? Yes. If it's not, then you have to reject the answer. And if I had to reject either one of those answers, then I wouldn't have a solution to those problems. It would just be no solution. So by definition of a log, your answer has to be in the domain. It has to be part of the graph, so it's got to be in its domain, meaning it's got to make sure that quantity is greater than 0. Totally forgot about that. Okay, so we don't ever want more than one log. We do not want more than one log. So remember, was it condense or expand that would make this go down to one log? Condense, okay? So if your problem has more than one log, you want to condense the logs down to one log. So that negative sign is telling me that I'm going to use what rule?
The quotient rule.
The quotient rule. So the x plus 2 is going to be divided by the x minus 1. So you want to condense any multiple logs that you have in your original problem. So if I'm subtracting those two logs, I want to condense those together using the quotient rule. Then you're going to ask yourself, is your log completely by itself? It is. So then you can rewrite it in exponential form. 4 to the first power is equal to x plus 2 over x minus 1. 4 to the first power is equal to x plus 2 over x minus 1. And if you'll put 4 over 1, to me, this problem is just easier solved to treat it like it's a proportion and cross multiply. So 4 times x minus 1 is 4x minus 4. X plus 2 times 1 is x plus 2. And then you'll just solve it from there. Subtract x from both sides. Add 4 to both sides. And divide by 3. Then we have to be sure to reject any value of x that is not in the domain of the original expression. Alright, so let's go back up here. In this problem we have two logs. So x plus 2 has to be greater than 0 and x minus 1 also has to be greater than 0. So let's check it out mentally. If x is 2 plus 2 greater than 0? Yep, so it's good in that log. Is 2 minus 1 greater than 0? Yep, so our answer can be 2. We don't have to reject it. That is in our domain. It would be part of the graph if we actually looked at the graph of this function. So that can be our answer. All right, 3 more. Everybody got 6? Everybody good? All right, 7. Log base 2 of x minus 1 plus log base 2 of x plus 1 is equal to 3. So again, if you have multiple logs in your equation, you're going to want to condense those logs. If there are 2 logs on the left-hand side, then you'll condense the left-hand side. If there's 2 logs on the right-hand side, you'll condense the right-hand side. So since we're adding, I'm going to put this step in here. Some of y'all might can skip it later, but since it's our notes, since we're adding, what are we going to have to do with the x minus 1 and the x plus 1? We're going to have to multiply them together. So some of you might can skip this step. I'm going to write it down. So we need to go ahead and multiply those 2 binomials together. So that's going to leave us with log base 2 of what? X squared minus 1. So if we multiplied it out the long way, you would get x squared plus x minus 1. Y'all with me? If you FOILed it out, you would get x squared plus x minus 1, and the x's would cancel, or maybe you can do that in your head. I don't know, whatever works. Okay? Now, let's look at the log. Some people might think the log is not by itself, but it is by itself. Some people might think that x squared is a power, but remember the power has to be on the outside. X squared minus 1 is just a quantity. Even though it's x squared, that's just your quantity. There's nothing being squared on that. So that log is technically completely by itself, and it's ready to rewrite in exponential form. So you're going to get 2 to the 3rd power is equal to x squared minus 1. And right now I want to make yourself a note. This is a quadratic equation. Why can I say that? You have a quadratic equation right there. 2 cubed equals x squared minus 1. Why would it be considered a quadratic equation? You got the x squared. So that means you could possibly have 2 solutions. So you got to kind of think quadratic here. It's not like the other equations that we've just solved out and you just had a plain old x. So we're going to cube 2, and then we're going to what? Add 1, and we're going to get x squared is equal to 9. So if we got that x squared and it just equals a number, we don't have to do a factoring situation here. A lot of quadratic equations we have to factor. That's when we have a trinomial. We don't have a trinomial here. So we'll just take the square root of both sides, and your x is going to be 2 things. It could be positive or negative 3. It depends on your domain, okay? So you've got to check. So right now we have 2 answers unless we have to reject one of those. So let's check positive 3. Let's go back into your original log. Is 3 minus 1 greater than 0? Yes. Is 3 plus 1 greater than 0? Yes. So you get to keep the positive 3. All right, let's check the negative 3. A lot of times negatives don't check. It doesn't mean that they can't check, okay? But a lot of times they don't check. Is negative 3 minus 1 greater than 0? No, it's not. So you have to reject it. Cannot be in your domain, therefore it cannot be an answer. So you just have one answer there. I know you've kind of reached your limit. I can see my time limit. I'm videoing these because I can't remember if I have a video for this. Once we get to about 20 minutes, the normal teenage brain starts to shut off. That's my data that I've collected. All right, last 2 examples. Somebody's going, my brain shut up a long time ago, like 2 weeks ago. This class is not a sprint, it's a marathon. Have y'all figured that out? Y'all do sprint, but y'all do it every once in a while like you. You do sprint sometimes, don't you? Like right before the quiz and right before the notebook? Yeah. There's a little sprinting in there, and then there's a little just sitting on the side, drinking your water, having your cup of tea. Okay, everybody locate the equal sign. Alright, so the left-hand side has one log, but the right-hand side has two. So let's just say the left-hand side's good. You're good. You just have one log. Let's go condense the right-hand side. Let's make it into one log. So the left-hand side already has one log. And by the way, what's the base of all of these logs? 10. So don't think there's not a base. Sometimes we look at that and we go, oh my gosh, what are we going to do? And by the way, in these equations, we're not going to get into anything. Everything's going to have the same base. You're not going to have to fool with that. So on the right-hand side, since those logs are being added, I bet y'all can multiply this one in your head. What's x plus 3 times 3?
3x plus 9.
Good job. Okay. Now, a really cool thing is going to happen right here, which is going to make your life a lot easier. Something really, really cool is going to happen. I know math is not that cool. I think it's really cool.
It's so cool.
It is so cool when you get to college and you're just breezing through some of those classes, or you don't have to take them at all. You're going to think that's pretty cool that you actually learned some math in high school. When you have a log on the left-hand side and a log on the right-hand side, think about what that means. That means log base 10 of 2x minus 1 is equal to log base 10 of 3x plus 9. So it really means you have the same bases. So if you have the same bases, the logs go away. But you have to have a log on both sides. You can't just drop one log. You have to drop the log from both sides. And then you come up with a fairly doable equation. Is this equation quadratic? No, it's not quadratic, so it's not going to be more difficult to solve. Get all your x's on one side and all the numbers on the other, and I think you end up with x is equal to negative 10. And before you circle that answer, is negative 10 in the domain? Well, that means that 2 times negative 10 minus 1 has got to be greater than 0, and x plus 3 it's got to be greater than 0, and if x is negative 10, that's not going to happen. And if it made any of those not greater than 0, it can't be in your domain. You would have to throw it out. So you all agree x can't be negative 10, and those values be greater than 0? All right, so we have to reject it. I don't really like that word, but it's rejected, and if that's the only answer you have, and it's not in your domain, then your answer is no solution, or you might see that circle with a line through it. Now, just because there were logs on both sides doesn't mean you're always going to get no solution. Some of those are going to have solutions. That was just the example that I picked. Okay? All right, I'm going to decide to stop because my example 9 is very similar to my example 8. So I'm going to stop here because you look like you have had it.